So welcome to lecture 19 of MCS 471 or MCS 507, a graduate course in mathematical, statistical, and scientific software. So last time we did graphical user interfaces. Today we look into web interfaces. Web interfaces and graphical user interfaces are in some sense being quite similar in the sense that the action is also determined by the user. The main difference, of course, with a web interface is that the browser is working as an intermediate between the user and the software which may be running remotely. So, web interfaces are extremely important. It's kind of an understatement. The purpose of this lecture is to try to give a feeling as a programmer, just by plain Python, how you can prototype a web interface, a basic web interface to some mathematical software. This might not be the fastest way how to, and perhaps certainly not the best way how to set up a web interface to software, but it may give you a feeling how to get started and what is involved and how things are working. So we can run Python scripts through browsers. In one sense, this is a specific instance of client-server networks where the server, where the client program is here the browser. So, and the client requests access and services to data from another computer. So the server in this context here is narrowed down to being a web server. So clients and servers, they can provide, a server can provide any service, for example, a database service. A client may be another program that sends requests for data to that database server. The layer on top of it could be a web interface on top of the client program. Okay, client-server program came with distributed networks. For example, I mentioned database administration. Then there is the protocol, the hypertext transfer protocol, which we see still in the URLs. So this defines a protocol between the communication between browser and web server. The browser being the client, the web server just the server. So this goes via a TCP IP connection. And here are the 4 steps in this connection outlined. All right. P is the Python in the LAMP system. So where Python is the scripting language that is going to serve for both the web server and the database. So Python is makes the combination between a web serving scripting language and database makes it happen. So what is explained in this lecture is with the Apache web server. So the slides were prepared via on a Mac and on a Linux workstation, but it should also, the same tools should also be applied in any web server environment. All right, so here is what we are going to demonstrate on the Apache, which runs both on the Apple and the Linux. So there are some differences between how Mac operating system and the Linux operating system, where the personal web pages are stored. On a Mac, this is the sites directory in the home folder of the user. In the uh, Linux work, this is public HTML. So there are the HTML pages, and then there are the Python scripts, and they are stored on Linux in this folder /var/www CGI bin, or in this library web server. Now, I should say this as the default installation. It is quite possible to configure Apache so that dedicated folders are being used. So if the web administrator is a regular user, and in some sense this is recommended, if something goes wrong with the security, you can set it up that the Python scripts run on the server computer within a regular user account. So with Python, we are going to write what is called CGI scripts. So everything that can be done today is running on the local host. So, and this falls well within the um, prototyping um, prototyping capabilities of Python. All right, so you can check whether Apache is launched. So here this is done this is demonstrated on Unix, so which the HPTT daemon. So to launch Apache, to launch the web server, you will need to have super user access on both the Linux computers and on the Mac on the Mac OS X. Okay, let's get started. So this is essentially a hands-on lecture. Let's first try our first script. So we need to do some setup. So if you are doing this on Unix workstation, you will need to, as a super user, start to editing the configuration files, and then also uncomment some lines so that users can, in their home folders, they can have scripts that will be serving. So one needs to make also available at the very bottom here the CGI module. Okay, so for a specific username, one needs to have a configuration file in the users folder of the Apache configuration. One needs to access the user privileges that require all granted. So this is the user configuration. After modifying the scripts, make sure that you restart the Apache. In the Mac, so the system preferences, the internet sharing must be set on. Okay, we are there then. So our first script starts with these two special symbols. So the symbol also being used for commenting, but it's not a comment. It's going to define the first line, defines the path to the executable. So this is the executable which Python interpreter that you want to use to serve the Python scripts. And our Python work scripts is in the current folder, or is in the folder, so it's in the user folder where you want to start serving on Linux, or it is in the folder where on Mac all the CGI executables are. Okay, so it's important we are printing, but we are printing plain text file into a browser window. So we cannot just do print and then whatever it is that we want to print. No, we have to indicate first that we're going to write plain text. The alternative is that we are writing HTML. So if you execute this on localhost, then if all is set up well with the right privileges, and make also sure that the executables, that the Python scripts are executable. So up to this in this course we have seen that we can run Python code within a JupyTer notebook or at the terminal prompt by typing Python and then the name of the scripts. Here, if you make them executable with the first line, the path of the Python interpreter, you can directly execute a Python script. And that is being done here in this setup. All right. You actually don't really need Apache. So if at this point in this time you tried to follow the instructions and you read the manual for Apache and it didn't work, don't worry. So you can actually in pure Python run your own web server. Again, it's not recommended to do this on a production level server, but this lecture is to prototype with localhost. Then you can actually run a simple my server script. So here is the script. The script is not longer fits everything in on the slide, so Python comes truly with batteries included. So it comes with a server. So we have to define what type of server that we are going to use and what kind of port number we are going to use. So note that I think you cannot use this script when Apache is running at the same time. So the port number needs to be available. So there should not be any other other services being running that are using this port number. So if you leave the server address empty, then like here, then localhost will be used. So we are importing the HTTP server here. Then we import the toolbox module of the Cgi scripts. We also enable, and that's very important here, often Cgi scripts are very difficult to debug. If you enable this, then you will enable the reporting. We will run the script from the current folder where also the scripts are that we will run during the demonstration. So the CGI directory is actually the current folder. Okay, and that's basically it. So we start the server by launching the script. We stop it by doing Control-C. So if that actually happens, so if we are having the serve forever, when the server comes up, we actually are launching the serve forever. The message is being printed to shut down the server type Control-C. So isn't that cool? We can run a web server from the command prompt. Okay, reboot, retry. So we start the script my server, and in the current directory we have the Python works. So we point our browser to localhost, specifying the port number 8000. Again, in the security settings, it should be that if you're operating with the firewall, it might be that the ports must be open. So that could still be a snag. But this should be sufficient for running and testing the scripts, what we are going to use in this lecture here. All right. Here is our hello world. We are printing a form, an HTML form. It is displayed in a browser. The hello is being shown, or actually, here you see this resemblance with a graphical user interface. We have three elements. I think the proper terminology now is elements. With graphical user interfaces, we speak of widgets. We have a label, enter a word. We have an entry widget. This is where we're going to put the word. And then we have the button that will activate a Python script. So this is the show form that gets printed. And then when the user hits submit, the process form is executed. And this script is then in the CGI bin folder. And here the interaction is just that the script confirms the word that was entered. Okay, so here it is. So this is the code in show form. So you see I updated the slides, so this is lecture 19. We have pure raw HTML. We have a head that will be showing up in the title of the browser window. We have a body, and in the body we define the name of the script that will be executed when the user hits the button, the submit button. So we have a form. So you see the beginning of the form defines the action, which is a Python script. Here you see the form contains three elements: a label, enter a word, then the text element that is then for to enter the word. So we can often already we can provide the size, and then we have the submit button. So every element has a type here. All right, then the code for the process form. When this form gets executed, there is something in the form that can be retrieved via the module CGI via the field storage. So we're going to print plain text to the browser. We're going to retrieve the value of the form. Now it is important that the word was the word that was being used over here. So here we can specify the name word. This should correspond with the key that is used in this dictionary format here. So we confirm, and this is in an exception handler. So exception handling is extremely useful when processing web forms. When the user has not entered anything, there will be a key error that will be generated. If you do not provide an exception handler, then your web service will crash. So it's very good to essentially provide this exception handler. It's also a test here on the enable, the toolbox, the error messaging. There's also a test on this here. All right. Work with HTML, the layout, to print the forms, to request the information, and then there is the Python script that processes the information. Nice separation of HTML code, pure HTML code with pure Python, but actually not such a flexible way to work. So I indicated the advantages and disadvantages. It has the advantage of separating the HTML from the Python code, but it forces you to bring up a new page in all the time, and that's not very useful. So it's often useful to work within one page, and essentially whenever an action is being made, a new page is being printed into the browser window. So this creates for a lot of flexibility. Okay, let's illustrate this. So we have our script where we first print a header. So now we are going to write HTML. So the printing of a header, so it is a function, but we print multiple strings. So we have the documentation string, which is the triple quotes, but then we have the printing, where we are printing strings of multiple lines long. The first line will always start with text HTML here. So now we write pure, nicely formatted HTML. So there is a parameter in this Python function, and that's the title that will appear in the header of the browser window. Okay, so then we have the main function here. So we print the header, and then the action will be the showing of the form and the retrieval of the words. So it will be exactly the same functionality, but defined by one Python script. Here is the processing of the form. Note that it appears at first that the formatting might be a little bit out of order, but that's because we are printing multi-line strings. So we are here checking whether we have already processed, whether we are at the first screen or not. So we had an exception handler, remember. So if there is something, if the key word is in the form, then we will confirm the form. Otherwise, we will print the form again that will be shown initially to the user. Okay, that's basically it. So for me, there would be now time to demonstrate this. I forego this. So let me work out a little bit more mathematical interface where numerical data is passed from a browser to the server. So suppose that we want to provide a web interface for a determinant, so or to pass any table of numerical information. So at first we ask what is the dimension. So the default is set as 2, so we can provide default values in Windows. If the user wants to have 3, then should change it to 3. So the user has entered 3, so that is reconfirmed. So in reply to the submission of the dimension, the user sees the confirmation printed in the entry, in the text element, and then an entire matrix, so 9 and text elements are being printed in a table format with a submit button. So writing HTML forms with scripts is extremely flexible, so you can write as many input elements as needed here. So you see, it's kind of important that we are working with small numbers, although when the user does not enter here anything, the matrix will be initialized to 0. Okay, so here is what the user entered in this example. And then the script replies with a plain text confirmation of the matrix. And you see we are using Python, and the determinant is being printed. So this is a web service to prototype an interface for computing determinants or for processing numerical matrices. Alright, let me explain how everything works here. So how is data now being passed from one form to the next? So one could do this via persistent data. So one can make somewhere a file that could be useful if you want to somehow checkpoint the dialogue, make sure that in case something crashes, you have a copy at the server side. So here we can make it so that the browser stores actually this information, so that the action that is being, so the information can actually be passed through an input element. Very similar how we passed information, how we set a default value when the HTML form was just launched. Okay, there is a main program here. So we have the printing of the header. Either there is a dimension or not. So if there is a dimension already, then we retrieved. It's important that everything that is stored in string format. So if we retrieve a numerical value, we cannot just leave it as a string. Here you see it's converted to an integer. So this script, it's the main script. It shows kind of the action. Either you are asking for a matrix or you are asking for a dimension if there is no dimension field available in the form. Okay, so the value too gets defined here. So you see the value that is printed in this text element. The name of the value is also important because that name dim is the key that we are going to use in the form. So there is a button. So the other element in the form is the submit. So the type is submit. We have a text element and a submit button. There is the web determinant that is going to process this script, this form. So the ask matrix, so that's the next level. So the action, the compute determinant is going to process the data in the matrix. So we are going to print the dimension. So you see the dimension here gets being printed as the value of the type. So here the input parameter to the Python script dim is used to set the value in the form. So that is the confirmation. So that's what the user sees. And then we have the entering of the matrix, so the printing of a table with the table records, and then for every table record consists of multiple table elements. So it's kind of nice. Every element has a name, and the name is generated with the row and the column indices of the matrix. So we have a matrix that is represented by an HTML table, and that table has rows and columns. So the I and the J become the name, come embedded in the name. So we have, if we have a 3 by 3 matrix, we have 9 input elements, and we will have 9 unique names corresponding to the row and the column indices. So that's how in the compute determinant we can then retrieve the data elements and define our NumPy matrix. Okay, that was the first script. So the second script, we now are fully in the NumPy world. So we are going to retrieve from the form the matrix. So the matrix will be initialized to zeros, and we will make the name and check. So by default, all the data is 0. So if the user did not specify anything, that's no problem, it will remain 0. You see that we compute the name, the string, based on the row index I and the column index J. We compute these indices in the name, and we query if that name is present in the form. If so, we retrieve the numerical value by converting the string into the float. And we confirm the matrix. This script then returns the determinant of the matrix. Okay, so in the main program, what do we do? In the main program, we are, so this is the main of the compute determinant. The compute determinant will only do something if there is a dimension number available, if the key dimension is in the form. If so, the value is then being used of the dimension, and the determinant is retrieved, so is computed from the retrieved values from the form. Okay, so this is the main principle of web interfaces. So one can have entry fields that can take any strings. One is not limited to just numerical data, but anything that can be parsed can be entered into the web forms. All right, for the last 5 minutes, I will say something about cookies. So we can store information at the client side by making a little bit more clever CGI scripts. So one can build a web counter, counting the number of times a website has been accessed. One can also pass data from one script onto another. The Python HTML HTTP module exports cookies. So we can set a date in a cookie. So we can set a label. And the cookies work like dictionaries. So in your browser, you can actually see the values of the cookies being set. They are depending on the browser. If on the same computer you're using different browsers, you're using then different cookies. So how do we compute with cookies? So there is value stored, just like a value in a string, and we can set values corresponding to keys. So this is a example on how we can use a cookie to count the number of visits. This is tested in the in an interactive Python script. So how can we retrieve just by getting the value, but you see here that with the right quotes around it, that the value of anything that gets stored is by default a string. So if you want to compute, we must first convert to an integer. That's done here. We convert and then we add 1 to it. So as we do the assignment, automatically the string will be stored, the string representation will be stored. Okay, so we can store, also we can initialize cookies essentially with dictionaries, so it's quite flexible. All right. To finish, let us illustrate the script cookie counter. So that is going to count the number of times we access a particular website. So we will see when the counter is already there. If there is no counter, we will make it and initialize to 0. Otherwise, we will increment the counter. Here in this prototype, we also display each time the counter value. Okay, here is the cookie counter. The check is first whether the cookie is available. If it is available, then we will retrieve it from the environment. Otherwise, we will create it. We will create the counter. If that cookie does already contain the number of visits, so we can store many things in that counter. If we just check whether we have already used the visits or not, if not, we initialize. Otherwise, we increment the counter. And then the main prints in plain text the visit of the counter. What is important here is that this is information that the text browser actually needs to be aware of. So the first thing that we need to print, we actually need to print the counter. So we need to get the counter, but then we also need to print it. So printing counter here is not really printing in the conventional sense. It's sending the information through. And then the printing actually happens after the formatting statement. Okay, I hope, so I had allotted 50 minutes time for this lecture. But I hope that with some very simple constructions, you can already prototype a very simple web interface. This is useful in learning to see how a web interface works, and this can already be very practical if you want to define a dedicated web interface to your software. If you want to provide a pre-release to your software, you can give to your alpha users a dedicated link, so the users don't need to install, and this has the benefit whenever you make a patch and you update the software on your server, all the users need to do is refresh their browser and just try the input again and see whether it works. So this is great. Should have pointed this out. This is not just static web pages. So if you set up a personal web page, now you can actually make dynamic web pages, and they print whatever is processed from forms. Okay, so there are some suggested exercises. So Apache is our default free and open source web server, but you can also set up web servers without Apache. So if Apache is not installed, if it's not running, if you're running this on a Windows computer, try the my server script and see whether you can use localhost. The first suggestion here for an exercise is to prompt the user for two integers in a form and then to reply with the greatest common divisor. You can export much nicer information. You can export a root finder, for example. So the last exercise here asks, so mpsolve has been a little bit our running example for making interfaces. So this is another type of very straightforward interfacing to an executable. So making a piece of software available to users who can handle a web browser. Okay, so the key point of this lecture is that with some very simple Python scripts, you can define a useful Python interface, a useful web interface. So I hope this was interesting. Thank you for listening to this lecture.